Hello, everybody. Once again, I am here with you for the new session, and which is again related with our topic, which is to be as an waves and oscillations are to be there. This paper already in this paper we have already seen the two units which is related with the waves and the stationary waves. And moving forward, we are looking for the free and forced vibrations, in which we have seen some basic definitions which are related with the forced and the free vibrations are to be there in detail. If you want to see the definitions regarding the free vibration, undamped vibration, damped vibrations, what is resonance, and all that things you will learn my previous topic or the video. You can go through that, and you can check exactly details what exactly definitions are to be there for these vibrations, and free and forced vibrations are to be there. Now, today's point is to be undamped vibrations. What exactly the relationship for these undamped vibrations is to be there. So, moving forward, what exactly meaning to be undamped vibration, and what is the relationship for this undamped vibration, that we will see in this video. Now, basically, what means to be as an undamped free vibrations are to be there. Already we have seen in the previous session, but still there is a gap. That's why we will see what exactly meaning to be undamped free vibration. So if suppose the simple pendulum or the body is vibrate freely in the vacuum, and pendulum is in the vacuum, then we can say body vibrates freely, and no resistance offered in its option, in its motion, sorry. So as far as it is in the vacuum, there is no resisting force is to be there, air is not to be present, and that's why the whatever be the displacement I have given, that with the same amplitude it will be continued, and there will be no change in the amplitude, as far as there is no frictional forces are going to be there, or there is no loss of energy in this in this particular vibration or the motion is to be there. And that's why we can say the body vibrates freely. Again, there is no resistance offered by the motion. Again, the amplitude will be remains constant. What is the amplitude? That is what the displacement I have given from the mean position, and that is going to be the constant. There is no change in the amplitude is to be there. And similarly, there will be no loss in the energy as far as the frictions are to be there. So such type of the vibrations are called to be as your undamped free vibrations are to be there. Now we are looking for this what is exactly the relationship is to be there for this undamped free vibration. Now याच्यामध्ये जे काय आपण व्हॅक्यूम मध्ये पेंडुलम जर ठेवला विथ द त्याला डिस्प्लेसमेंट दिला आणि कंटिन्युअस ठेवला, तर इट विल बी कंटिन्युअसली रिमेन ॲज इट इज. त्याचं जे काही व्हायब्रेशन असेल, त्याचं जे काही मोशन ऑसोलेशन असेल, ते कंटिन्युअसली किती 10, 15, 20, 25 किती वर्ष जर बघताल, तर ते दॅट विल बी रिमेन्स ॲज इट इज. ॲम्प्लिट्यूड विल नॉट बी चेंज. Why it is to be there? Because no air is to be there, or no frictional resistance is to be there. त्याला अडवणारं असं कोणी नसणार आहे, आणि त्या व्हॅक्यूममध्ये त्याचं जे काय ऑसोलेशन आहे ते कंटिन्युअसली कित्येक वर्ष चालू राहील. बिसाइड्स व्हॅक्यूम शुड बी 100%. So this is what the such type of the vibrations are nothing but to be called your free undamped vibration is to be there. Now exactly what correlationship is to be there to find out this, as we are aware about that the simple harmonic vibrating particles have the kinetic whatever be the kinetic energy for the displacement y is to be there, that I can, if suppose the wants to write, it can be written likewise to be as an basically with the case where it is to be as an if I want to find out the exactly the correlationships, or exactly the whatever be the relationship is to be there for the simple harmonic vibrating particle, it is nothing but to be given with this relation, and that is nothing but to be called your half m dy by dt whole square. That is kinetic energy is half mv square, we can say. M is nothing but to be mass, and what exactly dy by dt is to be there? Displacement is nothing but to be y. That's why displacement with respect to time, that is velocity, and the dy by dt square, that means velocity square is to be there. And that's why the simple harmonic vibrating particle having the kinetic energy, that is half mv square, is nothing but to be half m into dy by dt whole square is to be there. So again, the important factor as far as this correlationship is to be there, at the same instant the potential energy, if I wants to find out, because whenever the energy word is comes, it comes with the it is meaning to be as an total energy, that is kinetic energy plus the potential energy is to be there. Kinetic energy is this much amount, and the potential energy, if I wants to say calculate in that case, in the for the particle, it is nothing but to be half ky square is to be there. What is k? Is nothing but to be the restoring force per unit displacement. What exactly meaning? जेव्हा मी त्या पेंडुलमला डिस्प्लेसमेंट देणार आहे, तो पुन्हा रिगेन करण्यासाठी जी काही एनर्जी आहे, दॅट इज व्हॉट द रिस्टोरिंग फोर्स इज गोइंग टू बी वर्किंग. एनर्जी इन दॅट सेन्स फोर्स इज टू बी देअर. मी त्याला इकडं जेवढं न्यायचा प्रयत्न करेल, तो तेवढं वापस त्याच जागेवर येण्याचा प्रयत्न जे करणार आहे, दॅट इज व्हॉट द रिस्टोरिंग फोर्स पर युनिट डिस्प्लेसमेंट. मी जेवढं डिस्प्लेसमेंट देणार तेवढं तो इकडं, मी जितकं जास्त लांब नेईल तितक्या जोरात तो वापस येण्याचा प्रयत्न करेल तिथंच ॲज मीन पोझिशनला. And that is nothing but to be k is given with the restoring force per unit displacement is to be there. आणि ज्यावेळेस मला टोटल एनर्जी फाइंड आउट करायची, नो डाउट इट इज कायनेटिक एनर्जी प्लस पोटेन्शियल एनर्जी इज टू बी देअर. अँड दॅट्स वाय इन दिस केस इफ आय वॉन्ट्स टू say the total energy at any instant is to be there at any instant. Why it is to be any instant? What is to be there meaning? Time is going to be continuously and the oscillations are going to be continuously, and that's why at that instant is to be the word used. Now here the total energy at any point at any instant is nothing but to be kinetic energy. This is your kinetic energy, and this is your potential energy is to be there. So addition of these two, that will be giving you total energy at any instant is to be there, and it is nothing but to be half m into dy by dt whole square plus half k y square is to be there. So this is what the total energy is to be there, kinetic energy plus potential energy in that case. Now for the undamped harmonic oscillator, this total energy remains constant. Why it is to be there? Because there is no frictional forces are going to be working, and that's why for the simple harmonic motion or the oscillator this total energy remains constant. म्हणून ही एनर्जी जी आहे ती कशी राहणार आहे? That is going to be the constant one, and that's what it is to be having the relationship is to be written to be as an is equal to constant. म्हणजे half m into dy by dt whole square plus half ky square is going to be the constant. Why it is going to be constant? Because the whatever be the simple pendulum or the simple harmonic wave motion or oscillator is to be there in this undamped vibration or in this undamped conditions, we can say there is no frictional forces are working, and due to that it will remains as it is constant, and that's why the energy will be remains constant. And if I am differentiating this particularly with respect to t, then the values are going to be for what exactly if I am differentiating this, it will be 2 ethyl. जर समजा मी ह्याला differentiate केलं तर it will be coming to be as an 2 ethyl, आणि no doubt 2 get cancel, m into d2y by dt square plus with respect to ti इथं काहीच आहे ना, हा 2 पुन्हा इथं येईल, 2 into 1 by 2, that 2 cancel, and ky is nothing but to be constant is to be there. What is the, that is what the differentiation with respect to t is to be there. So this is what the value, if you look at this case, it is somehow given in this relation, that is m d2y by dt square plus ky is equal to 0 is to be there. This is what the differentiation. And if I am dividing throughout this equation by m, जर समजा m ने मी divide केलं throughout equation ला, that is to be m by 0, 0 by m is also to be 0, म्हणजे m by m will be cancel, k by m आणि the 0 by m that will be remains as it is. मग त्याच्यामध्ये रिलेशनशिप काय येईल? d2y by dt square plus k by m into y is equal to 0. 0 by m will be 0, and that's why the new relation I have, the d2y by dt square plus k by m into y is equal to 0 is to be there. And this relationship is nothing but to be as far as equation 3 is going to be similar with the another one relation, and that is nothing but to be with the d2y by omega square plus d2y by dt square plus omega square y is equal to 0. and equating this, मग हे जर समजा मी या इक्वेशन सोबत इक्वेट केलं तर काय होईल? इथं d2y by dt square, इथं d2y by dt square, इथं y, इथं y, आता उरलं कोण? k by m आणि इथं ओमेगा स्क्वेअर. म्हणून मला काय लिहिता येते? omega square is equal to k by m, and त्यावरूनच omega is equal to how much? Under root of k by m is to be there. So this is what the relationship will be there. And for equation, for the general solution for this equation 4 is nothing but to be your simple harmonic wave motions as a simplification, or the solutions are bagitla, it will give me nothing but to be y is equal to a sine of omega t minus alpha is to be there. As far as a is nothing but to be amplitude, y is the displacement, omega is the angular velocity, t is the time instant, and the phase alpha is to be there. So in this case, y is equal to a sine omega t minus alpha is to be there. And if you are putting the value of omega, that will be y is equal to, the new relation will become y is equal to a sine of into under root of k by m t minus alpha is to be there. This is what the new relationship is to be found. According to this, जर समजा मी ह्याच्यावरून जर फ्रिक्वेन्सी कॅल्क्युलेट करतो म्हणलं तर दॅट विल बी अगेन फ्रिक्वेन्सी ऑफ द ऑसिलेशन इज नथिंग बट टू बी एन इज इक्वल टू ओमेगा बाय ट्वाइस पाय इज टू बी देअर. आणि मग त्याच्यावरून जर समजा मी फ्रिक्वेन्सी कॅल्क्युलेट करायचं जर म्हणलं तर इट विल बी नथिंग बट टू बी एन इज इक्वल टू ओमेगा बाय ट्वाइस पाय इज इक्वल टू, मग काय होईल, 1 बाय ट्वाइस पाय अंडर रूट ऑफ ओमेगाची व्हॅल्यू जी काय आहे under root of k by m is to be there. This amount of frequency for that oscillation for the undamped vibration, free vibrations are to be there. The case undamped free vibrations, the differential equation in that case we can write d2y by dt square plus k by m into y is equal to 0. This is what the differential equation for the undamped free vibrations are to be there. For the MCQ point of view, this equation may be asked, what is the differential equation for the undamped vibration? You should have clear in your mind that the relationship will be like this. This is the somewhat 1 point for the 1 mark in that MCQ. There may be a question, what is the frequency of the oscillation for the undamped vibration, and that time you should aware about that it is nothing but to be n is equal to 1 by twice pi under root of k by m. And this is what the relationships are very much important as far as the undamped free vibrations are to be there. So moving forward, this is what the relationship for this undamped differential equation. We will end this session with the differential equation of the undamped free vibrations is nothing but to be d2y by dt square plus k by m into y is equal to 0. I am separating this part for undamped and damped. Actually I want to continue with the damped vibrations are also to be there, but separate videos are making for time and the space is to be there. That will uploading the file, it will take a little bit time. So be careful about the again your health, and be at home and be safe. Till then, thank you and take care.